So chapter 7, this is where we begin with the confidence interval. So chapter 6, we try to find the probability of the item or the area underneath the curve. Now in chapter 7, we want to estimate, we want to guesstimate. If we don't have the population mean, we want to guesstimate what will be the population mean, because again, not all the time that we have a population mean, right? So before we talk about a confidence interval, let's take a look at a few definitions that we will encounter in this chapter 7 and chapter 8. So the first thing is the point estimate. The point estimate is basically a single number that we want to estimate the value of the parameter. So whatever you want to estimate the parameter, meaning the population item, we need a small point. We need one center item to estimate that point. So again, for us, the point estimator for 7.1 is the mean, which is the sample mean, will be your point estimator for your population mean. So reminder, I told you guys in chapter 1, and as we progress to chapter 7, you have to know the difference between the population versus the sample. So in this chapter, we will use a sample item. We will use a point estimator, which is for us a sample mean, to estimate the population mean. We don't know what the population mean is, but we can use the sample to kind of guesstimate where the population mean fall between. Okay, so the confidence interval is just basically, again, an interval, just as the name, the interval that estimates the value of the population. Where will the population value fall between, right? And to construct this confidence interval, we need to know what is our confidence level. And again, the confidence level is just basically the percentage between 0 and 100. So most likely you hear them say with 95% confident, meaning again, we are 95% confident that the population mean will be between these two values, whatever the two value that you try to estimate. Okay, so again, this confidence level, they will give you, they will ask you, they will tell you to construct this level, right? So again, it's always between 0 and 100%, which is, again, that's your maximum percentage, right? Which is the maximum probability as the same. The other thing that we have, which is, this is the most important thing in this chapter 7, by the end of today, you probably forget what margin of error is. By the end of today, you probably say, oh, we don't need it. But again, we have to point this thing, or I have to point this out to you guys, so that if your homework or your quiz question asks you to construct, or not to construct, but to calculate the margin of error. The margin of error is basically a number that contain your estimator. Pretty much is a kind of a number that you add and subtract to construct your confidence interval, as you will see in a little bit later. So this is here how to compute, how to find the margin of error, which is, to find the margin of error, you need to find a critical value, multiply that critical value to the standard error. So you probably say, okay, so what is a critical value? Which is, again, a critical value is just basically, to be in short, is a z-score that contain your level, your confidence level. Pretty much, as you will see a little bit later, that we deal with this standard normal curve, and then the critical value is basically between what two value contain my confidence level, contain this area, or contain this percentage. Okay, and again, the last thing we have is the standard error, which is in chapter 6. The standard error is just the population standard deviation divided by a square root of n. Okay, so this is the three things, the first three is just a terminology for us to communicate. If we ask you construct a confidence interval, you know the confidence interval, you need a confidence level, and you need a point estimator. Okay, and the last three is pretty much, the last three is what they will sometimes connect math on the quizzes, on the test. They ask you to find the margin error by itself, find the critical value by itself, or find the standard error by itself. Okay, so in order for you to find a margin error, you need a critical value and you need a standard error. Standard error is easy. A critical value, this is what we're going to do. So let's take a look at this thing here, which is how do we find a critical value, right? How do we find this thing here, which is there are a few items. So how do we find an uncommon critical value? And I will tell you all the common one. The common one is easy to find. The hardest thing is on your homework if they ask you for the uncommon one, right? So how do we find a critical value, for instance, 80% confidence interval? So this is what we have is, like I mentioned, your confidence interval. The confidence interval, the 80% is your confidence level. The confidence level meaning, again, this is your bell-shaped curve. This is your standard normal bell-shaped curve as we've been seeing, which is the confidence interval or the confidence level is basically the 80% in the middle. This is the interval we're looking for, ladies and gentlemen. This right here, the yellow highlighted item, that is my 80% confident, meaning again, between these two number, whatever the z-score here and whatever the z-score here, that two number contain 80% of my data or my confidence level, as you will see later. Okay, so if they ask you to find a critical value for the 80% confidence interval, which is again between what two value do we have? So looking at this thing here, if you go back to your test, right? If you look at this thing here, this is very similar to your previous test, which is they ask you to find a z-score that contain the middle 80% of your data or the middle 90% of your data, right? So that's what the confidence interval is, or this is what the interval we're looking for, is the interval that contain the middle, whatever confidence level they ask you. So if we know that in the middle is 80%, so now what do we need to do? Well, if the middle is 80%, do you agree that we take 100, which is the maximum, minus the middle 80%, that will give us 0.2 or 20%. And if it's 20%, and as you can see, we have two items on the left and on the right side, which is 20%, we divide this by 2. Do you agree that I have 10 on the left and 10 on the right, which is, again, the same item on your previous test, which is, again, how do you find a z-score here? So if we know the area to the left, this is what we need to do, which is, again, the area to the left is 0.10, which is 10%. Then we can use the inverse norm for our calculator, right? Inverse norm feature in our calculator to find the z-score, which is, again, inverse norm. What is the area? 0.10. What is the mean? The mean is the standard one, which is 0. And the standard deviation is 1, which is the standardized standard deviation, right? And again, if you do this thing here, if you type in your calculator, which is, again, if you type in your calculator 0.10, 0, 1 for your inverse norm feature, then this is what you have, is you have 1.28155 something. But again, we have 1.2852, which is, again, most of the time critical value, they have 3 decimal places. But again, the reason why I put positive and negative is because, again, that they are symmetric, ladies and gentlemen. So again, if this number on the left side, it will be a negative 1.282, and on the right-hand side, it will be positive 1.282. Okay, so this is what we have, which is, again, we're just using what we learned in chapter 6 to find this critical value. And in short, a critical value is just a z-score that contain the middle confidence level or the percentage in the middle. Okay, it's not the left side of 80, it's not the right side of 80, it's the middle 80. Okay, and again, similar, let's try one more, which is, again, 80, probably you will see 80, it will be a common critical value. Let's say if they ask you for find a critical value for a 94% confidence interval. Again, the confidence interval is the same as not the same, but the difference between confidence interval and versus the confidence level is the confidence level is the percentage. The confidence interval is the two z-score contain your percentage. Okay, so if you look at this thing here, again, same as before, whatever the confidence interval is the middle percentage, which is, in this case, the middle percentage is 94. Just like before, if I take 1 minus 0.94, I have 0.06, which is 6%. But because of the 6%, because I have two tail, which you will hear me say more when we get to chapter 8, we have two tail, we have the left tail, and we have the right tail, which is, again, we have to divide by 2, which is, everybody see that the 3% plus the 94% plus the 3%, that will give me the whole 100%. Which is now, if I have this item, which is, again, I use the inverse norm, which is what is the percentage on the left, which is 0.03, which is the percentage on the left, which is now, all I have is, once I have this, I will see that the z-score will be 1.88. I think it's 1.8805 something. But again, this is what we have, which is on the left-hand side will be a negative number, and on the right-hand side will be a positive number. So to find this critical value, if it's uncommon, and again, you probably say, so what is the common critical value? The common critical value is easy to find, and I will tell you a bit later. But again, for any uncommon like 82 or 96, something in terms of that is not considered common, this is how you have to find it. You have to take one, subtract whatever your level of confidence level is, and then divide by 2, because you will always have two tail. You will always have a left tail and the right tail. The highlight, sorry, the yellow highlighted item right here, you will always have, because whatever your confidence interval or your confidence level is, always include or cover the middle percentage of your standard normal. Okay, so first of all, question with
pardon
this.
Me,
yes.
Pardon me, Dr. Tran. So in that case, then will your mean always be 0 and your standard deviation 1?
Yes, because it's always, we will always deal with this standardized normal curve. So it's always, the mean will always be 0, and the standard deviation is always 1. Whenever you try to find a critical value, yes. Another question?
Mr. Tran, I didn't get 1.881 on my calculator. I don't know if I'm typing it wrong.
What did you type?
I did invoice norm.
0.03.
Oh, I put 0.06. There we go.
You have to divide by 2, so 0.03.
Okay, I got it. Thank you.
All right. So, another question here.
Yeah.
Yes.
In my calculator came up negative 1.881.
Yes.
So that's fine.
No, you have both. You have a negative, which is on the left, and it's symmetric, so it's positive on the right. So it's the same value, just on the left-hand side right here, it will be negative 1.881. And on the right-hand side here, it will be positive. So the critical value will always be positive and negative, because you will always have one on the left and one on the right. So again, if you put 0.03, you will have a negative 1.881. If you put 97, then you have a positive 1.881. I did not do the 97 because it's the same number. Because again, to find this number right here, if you want to find this number right here, then you have to take 0.3 plus 0.94. That will give you 0.97. So again, if you put inverse norm 0.97 comma 0 comma 1, you will get a positive 1.81. That's why I skip it and I say it's a positive answer and a negative answer. Okay.
Okay.
So let's take a look at this thing here. Let's take a look at notation first, and then we will mention about the common, so again, a notation, a little bit different notation that you have, which is, again, instead of say the area between, we have this notation, which is we have this Z alpha. So Z alpha is basically tell you that this is the area on the right. They change it a little bit in terms that this here Z alpha, which is, again, Z alpha is basically the area to the right of the Z score to the right, meaning whatever the area they give you is the area to the right of that item. It's a little bit different in terms that, yes, the inverse norm we use in the area to the left because the calculator can only calculate to the left. But now the Z alpha is basically is referred to the area to the right of the alpha. Okay, so one thing is this area, this right here is say area equal to 1 minus alpha. The area is your level of confidence. Okay, so the area here is say the area is basically, this is the percentage that you have. So if you can see, last time we have 94%, right? 94%, which is the area is 94, right? 0.94. And again, 1 minus alpha, which is how do I find alpha, which is do you agree that to find alpha, I either add alpha over and minus, which is again, 1 minus 0.94 is 0.06, which is the 0.06 is your alpha, right? So again, the alpha is basically the area on the right of whatever the leftover on the right, right? It's because that we have the area, the leftover is 2. That's why we say, well, alpha, which is 0.06 divided by 2. That's why we call it Z alpha over 2, which is basically tell you the remaining area divided by 2. Okay, so looking at this thing here, which is again, is this, looking at this thing here, that's why I mentioned that we always have a positive and a negative Z score, which is on the left-hand side will be your negative Z, and on the right-hand side will be your positive Z. Okay, so again, the notation, as you will see, you hear me say that Z alpha over 2 is basically tell you that the Z score, that whatever the leftover item is divided by 2, which is the left-hand side and the right-hand side. Okay, so looking at this thing here, so what is a common critical value, right? So a critical value, like I mentioned, the most important thing in this chapter, as you will see, is you have to know the critical value. Without the critical value, you cannot find the margin of error. And without a margin of error, you cannot find a confidence interval. So this, in your table 8.3, your table appendix 8.3, they list out your common critical value for you, which is, this is the common critical value in terms of, we did this, ladies and gentlemen, remember we say the confidence level of 80%, right? 80%, this is what we found out in the earlier, which is 1.282, which is again, this thing here, this is your confidence level, which is again 20%, 50%, 80%, 90%, 95, 98, 99, 99.5, 99.8, 99.9. So again, the common one is basically 95 and 98 and 93. This is the 3 common one that you will see that they will use a lot. Okay, so again, if they ask you for a critical value for a 95% confidence level, then again, the critical value will be 1.960. If they ask you for 99% confident, then the critical value will be 2.576. So again, for now, this is all I want you to look for. This is all you need from table 8.3. Tomorrow, we will look at table 8.3 as a whole table, and you will see the difference, and we will explore that table a bit. But for now, in 7.1, this is all you need from the table appendix 8.3, which is the Z score, which is this is the Z score. And again, this is your Z critical value, or the critical value of Z alpha over 2. Okay, and again, if it's reminder, this thing here, they only give you a positive number. So if it's on the left side, you just take this number and put in a negative. Everybody see that? And again, your critical level is right here. Like I say, so if they, on your homework, if they say find a 92% confidence level, well, that is an uncommon item, which is you have to take 100 minus 92, divide that by 2, and do the inverse norm. Okay, which is what we did before. Okay, but again, if they ask you for 99.5, then the critical value is right here. You don't have to do any inverse norm. Everybody see that? So before we do a confidence interval, before we construct the confidence interval, there are a few assumptions that we have. The first assumption we have is the population standard deviation, or our population have to be a normally distributed. Okay, that's what we want to, which is again, In this chapter, we will know the population standard deviation, but most of the time we won't. And when we get to 7.2, that's what we're going to do, is what happens if we don't know the population standard deviation. So for now, 7.1, we're still good to go because most of all the problem here, we know the population standard deviation, okay? So again, this is the other two assumptions that we have to have is your sample have to be random, meaning again, you have to randomly choose. You cannot be biased and just choose and not the other. And the other thing is reminder your standard error, right? Your standard error, which is again your central limit theorem, which is again your item have to be, your n have to be bigger than 30. If it's not bigger than 30, then you have to know that your population is approximately normal, right? It's either or. It's either you don't have bigger than 30, or we know that the population is normal. If we know the population is normal, doesn't matter how many sample we need to take. We know that the population is normal, then again, we only need 10 is fine. Because eventually it will come out to be a bell-shaped curve, a normal distribution, okay? So it's the same assumption as before. It's just that now we deal or we construct another number, okay? So let's take a look at this problem. Let's throw everything at you. Well, not everything. So here come the 5 steps. Here come the 5 steps that you guys need to construct a confidence interval. Okay. So again, this is the 5 step is again, first, most of the time the assumption will be satisfied, which is again, the 2 assumptions before, which is you either have more than 30 or your population is normal, or the other one was randomly selected, right? So the first thing is we need to find a point estimator, which is most of the time your point estimator will be your sample mean. Your sample mean is a point that we use to guesstimate, to estimate the population, right? The second step is we need to find a critical value. And again, if it's uncommon, you use your calculator to find your critical value. If it's a common, then you just look at the last row in your table A1 or the previous item that I have. The third item is we need to find a standard error, which is reminder the standard error. Well, actually, we need to find a margin of error. But to find a margin of error, we need to find the standard error, which is reminder that standard error is the population standard deviation divided by a square root of n. And again, to find a margin of error, you take a critical value, the z alpha over 2 critical value, times the standard error. And then here come, after all those 3 steps, here come the step 4, which is now we construct the confidence interval. And your confidence interval is this, ladies and gentlemen, is basically all you have to do is take the point estimator, which is your mean, add and subtract, I should say, add and subtract your margin of error, which is basically you take x bar plus or minus. Well, you have to plus and minus. So because if you plus, you have a bigger number, which is the right-hand side. You subtract, you have a smaller number, which is the left-hand side. Which is, again, this is your confidence interval, which is, as I mentioned, if you take your point estimator minus the margin of error, you have a lower limit. Your population mean is right here. And if you take the point estimator, which is the mean, plus the margin of error, then you will have a upper limit, which is your right-hand side, which is, again, the interval, which is your population mean is between that 2 value, okay? And the last step, you have to interpret your result, which is most likely you just say, we are 95% confident that the population mean fall between these 2 values. We are 99% confident, or we are 80% confident. Right? Basically, that's what you interpret your result. Okay, so again, let's take a look at this step by step in terms of the problem, which is, again, let's take a look at this thing here. Let's say that this is our problem, ladies and gentlemen. The mean test for a simple random sample of 100 students was 76.3. The population standard deviation of the test is 15. Construct a 98% confidence interval for the population mean. So looking at this thing here, again, I have 100 students take this test. And I know that previously, last year's, the same test, the standard deviation is 15. Now I want to use this year's 100 students to guess if I give this test to the whole population, what would be the average, right? That's what that's our goal here. Our goal is we want to guess if the whole population take this same test, the same 100 student test, what will be the population average? What is the average fall between, right? So again, how do we do this thing here, which is, again, we know that we have more than 30, we're good to go. We know that it's random, we're good to go. So looking at this thing here, we know that the n is equal to 100. The x bar, which is reminder, the x bar is your point estimator, which is your mean, which is your sample mean, that is your point estimator, which is we got the point estimator. And now everybody see that 98%. This is your, pretty much right now, this is your Bible. And again, on the test, you will have this thing here. It does not look like this, but you will see that it's this item. So everybody see that 98% confidence interval, which is, that is my common critical value. So everybody see that I need to find the second step, I need to find a critical value, and the critical value, I just look at this chart, and the critical value is 2.321. Now the third step, I need to find a margin of error, but to find a margin of error, I need to find a standard error first. So what is the standard error? Reminder, the standard error is the population standard deviation divided by a square root of n, which is, again, 15 divided by square root of 100, which is 15 divided by 10, which is 1.5. Everybody see that that is my standard error. And to find the margin of error, this is what they tell me is take the critical value, multiply to a standard error. That's my margin of error, which is, again, if I take this critical value, which is 2.326, multiply to 1.5, I have 3.489. So that is my margin of error. That's how big of my margin is. But the margin of error is a plus and minus, which is what does the plus and minus come in. This is what they tell you to do is take the point estimator. Take the point estimator, which is, what is my point estimator, which is 76.30. Subtract your margin of error, which is 3.8. Everybody see that this is what they tell you to do is take this point estimator, which is 76.3, subtract your margin of error. That will be your lower limit. Take your 76.3 plus the margin of error. That will be your upper limit, or your upper boundary, or upper interval. Okay, so if you do this thing, everybody see that this is my interval. My interval is, I guesstimate that the population mean, if the whole population taking this test, taking the same test that this 100 students took, the whole population take it, then the average of the whole population will be between 72.8 and 79.7. Okay, I don't know what the mean is. I don't know the actual mean is, but I guess that is between these two values. And that is the goal for chapter 7, ladies and gentlemen. We want to use the data we have to guesstimate the population, to guesstimate what will happen if the whole population do whatever the story is. And again, this is what we interpret, right? We interpret, most of the time you will say this, we are 98% confident that the population mean will be between these two values, 72.811 and 79.789. So again, that's basically what we will do in this chapter 7 here. Chapter 7.1, 7.2, 7.3 is the same. We try to construct a confidence interval. It's just that there are different techniques. If there are, for this one here, we know the population standard deviation. They give us this. They give us sigma. In 7.2, they don't. And if they don't, we have to do something a little bit different. Okay. But again, looking at this thing here, everybody question with the step. I know it's a long part, you know, it's